I'm Arun, and I'm going to be helping you with this problem. So after reading this problem, what you want to do is write down the 6 variables. So you have initial distance, you have final distance, you have initial velocity, final velocity, you have acceleration, and then you have time. So what you want to do right now is find the given variable. So right here they have that the top of the cliff is 60 meters high. This is going to be your initial distance, and then then you can infer that your final distance is going to be 0 because the rock is falling all the way to the ground. And then it gives you an initial velocity of Brendan throwing the rock up at 10 meters per second. And you know that velocity is what you're trying to find because that's what the main question is. Acceleration is always going to be negative 9.8 meters per second squared due to gravity. And the time we don't know either, but we may not need it depending on the kinematic equation that we find. So if you look at your kinematic equations, you immediately find that you only really need these 5 variables, and that there's an equation that covers these and can give you the final velocity. And that is v squared equals initial velocity squared plus 2 times acceleration times the quantity of final distance minus initial distance. So what you have to do here is square root it to get rid of this exponent. So you end up with the square root of this whole term. Then all you have to do is plug in each value into here and just plug and chug into the calculator, and then you'll get your final answer. So you get 10 squared plus distance is, and then you'll end up with the final answer of 35.721 meters per second. But if you look at this answer carefully, it may not make sense because the initial velocity was thrown up and it was paused up, and this rock is going down and it's negative. So if you're having these doubts, you're actually right. The answer should be negative because it's in a negative direction. So I hope that
this is Ryan, and in this problem we will be solving for the peak, the height at the peak, and the trajectory. But before we can do that, we first must determine what variables we do know and which ones we don't. So in this problem, we don't know the final distance. We know the initial is 60. The initial velocity is 10 meters per second. The final velocity at the peak is 0 in all cases. The acceleration is 9.8 due to gravity. And the time, we don't know. So before we can find the height at the peak, we first must find the time. So in order to do that, we can use this equation. We know the final velocity is 0. The initial was 10. The acceleration is 9.8. And all we have to do now is solve for the time. So I will do some algebra. And we should get the time to equal 1.02 seconds. So now that we know the time, we can figure out the final distance. So let me just relist the variables that we know. The initial distance is 60 meters. The initial velocity is 10 meters per second. The final velocity is 0 at the peak. The acceleration due to gravity is negative 9.8 meters per second squared. And the time that we now know is 1.02 seconds. In this, we will be using the quadratic equation, which goes like this. The distance equals half times the acceleration times t squared plus the initial velocity times time plus the initial distance. So now from here we just plug in our values. So half times negative 9.8 times 1.02 squared plus the initial velocity of 10 meters per second times the time again and the 60 meters. And from there we just simply put this in all in a calculator and we should get 65.102 meters. I hope that helped. And yeah.
Okay, so in this problem, we're going to try to figure out what would the velocity of the rock be when it hits the same initial height it started from while falling off the cliff. So we know that the initial velocity was 10 meters per second. And now we have to figure out what the final velocity is. So actually, you can do this without using any math at all, and the answer will be just 10 meters per second as well. Why is that? In any two-dimensional projectile motion, the projectile moves in a parabola. So whether it's like this, like this, like this, each opposite side, if this was, symmetrical like it should be, the velocity will be the same. And at the top of the parabola, the vertical velocity, though in the y direction, will be 0. So when velocity is 10 here, velocity will be 0 here, and then velocity will be 10 here again on the same height. Well, actually, negative 10, since it's going down now.